Okay, so I will again share my screen. Again, we will start our lecture. I was talking about the JK. The disadvantages of RS flip-flop and D flip-flop, they are removed in case of the JK flip. JK flip-flop is one such flip-flop where there is no invalid step, as well as there are two inputs. Okay, so RS flip-flop has the advantage of two inputs, but there are invalid steps. D flip-flop has the advantage of no invalid step, but there is only one input. So JK flip-flop is such a flip-flop which removes the drawback of RS flip-flop, that is, there is no invalid state in case of JK flip-flop, as well as there are two inputs, J and K inputs, which is the drawback of the D flip-flop, that is also improved upon in case of the JK flip-flop. Now we can see the structure of the JK flip-flop, how the JK flip-flop is. Okay. Instead of using two input AND gate, now I will be using three input AND gate. Okay. So one input is clock, as we know. Second input is J and K, and the third input is this, as we know, this is Q and this is Q bar. Okay. Now if I connect this Q bar correct. So here I am getting Q bar and here I am getting Q. This type of cross coupling, Q connected to K side and Q bar connected to J side. This is called as cross coupling. This cross coupling is a main important feature of the JK flip. Now let us assume, let us say how this flip flop will work, how it will work. Okay, initially we say that clock is 0. Okay. Here I don't have any space for drawing the truth table. So I will draw it here. I will say clock J, K, Q, and Q bar. Okay, if the clock is 0, then both the AND gates inputs will be 0. This is RSP clock. RSP. Okay. Whatever may be your J and K. If R and S both are 0, 0, it will enter into the last. This will be the last. Okay, so if the clock is 0 and whatever may be your J and K inputs, the outputs will remain in the last state. Okay. Now, if the clock is 1, and if both J and K are 0, as we know, if both the inputs are 0, the output of the AND gates will be 0. It will remain in the last state. It will remain in the last state. Okay, let us assume that the last state is 0, Q, and therefore Q bar will be 1. Let us assume this. You can assume in a opposite manner also. That is Q1 and Q bar 0. Doesn't matter. So if your clock is 1 now, and if J is 1 and K is 0, let us assume like this. J is 1 and K is 0. Now what will happen? Now clock is 1. So both the sides, the clock is 1. J is 1. Here J is 1 and K is 0. So if K is 0, output of the AND gate will be 0, no doubt. Now Q bar is 1, last state. We assume that Q bar is in the 1 state. So now for this AND gate, J input is 1, Q bar is also 1, clock is also 1. The output of this AND gate will be 1. Because all the inputs are 1, output of the AND gate is 1. If S becomes 1, what will happen? Q will become 1. When Q becomes 1, Q bar will become 0. Correct? Now if keeping this clock 1, if I now make J0 and K1, now what will happen? If the J is 0 now and K is 1, now what is the state of Q bar? Q bar is now 0. What is the state of Q? Q is 1. So all the three inputs to the lower AND gate are 1. The output of this AND gate will be 1. Output of this AND gate will be 0, no doubt. When it is 0, 1, what will happen? When R is 1, Q will become 0 and Q bar will become 1. Okay. These are the normal steps. Now, the best condition is when clock is 1 and if both J and K are 1, now what will happen? If both J and K are 1, now what will happen? Now J is also 1, K is also 1. What about Q and Q bar? Q is 0 and Q bar is 1. So here this output will be 1, this output will be 0. So what will happen? Q will become 1 and Q bar will become 0. Okay. If clock is again 1, what will happen? And J is 1, K is 1. Now what will happen? upper AND gate output will be 0, lower AND gate output will be 1. In that case, it will be 1, sorry, it will be 0, and this will be 1. So this will continue. Okay, from here onwards, you can see J and K are 1, J and K are 1, J and K are 1, clock is also 1. What is changing? Q is changing from 1 to 0, 0 to 1, 1 to 0. Q bar is changing from 0 to 1, 1 to 0, 0 to 1. So this is called as toggle. It is toggling, toggle state. This is the importance of the JK flip-flop. There is a toggle state in case of the JK flip-flop. What do you mean by toggle state? Toggle state means this type of state, where the output is continuously changing with a clock. Whenever I make the clock 1 and 0, 1 and 0, what will happen? It will change the state. Okay. Now, what is the drawback of this? The drawback of this is if the clock is 1, okay, the outputs will change very fast. 1 0 1 0 1 0 1 0 like that. Okay, Q and Q bar will alternately change until you make the clock 0. As soon as you make the clock 1 and J and K are 1, the output will continuously, within a fraction of a second, they will change their states. And you will be unable to notice that. You will be unable to notice that. So, clocked J flip-flop, JK flip-flop has that disadvantage that you are in the toggle state, the outputs are going to change very fast and you will be not able to see that they are toggling from 1 to 0 and 0 to 1. You will be unable to see it because they are very fast. They are toggling very fast. You will feel that Q and Q bar both are remaining in the one state, on state, as you feel like that. So, how to solve this drawback? That is toggling becoming very fast, unnoticeable. Instead of using clocked JK flip-flop, I will use triggered JK. Triggered JK. Now, what is difference between a clocked JK flip-flop or clocked flip-flop and triggered flip-flop? That we will see. Okay. Clocked versus triggered. Okay. In the clocked flip-flop, the clock input will remain 1 until and unless you make it 0. Okay, so this is a long time. Whereas in case of triggered, it will remain 1 for a very short time. Okay, it will remain 1 for a very short time. Okay. Now, in case of triggered, you have two types of triggers. One is positive edge, and one is called as negative edge. Okay. Positive edge triggered means the input is changing from 0 to 1. And negative edge triggered means the trigger input is changing from 0 to -1. Right. This is called a negative edge. Now, how we get this type of trigger? So there is a circuit called as RC triggering circuit. This is C. This is R. And if I apply a clock here, clock input, I will get triggered out. Means if I plot the waveforms, this is your clock. Clock is going from 0 to 1, 1 to 0, 0 to 1, 1 to like. If you look at the output, this is clock input, and this is the triggered output. What do you find? At this instant of time, okay, the capacitor will pass all the voltage at the output, and then the capacitor will charge immediately. Correct. It will charge immediately from this side to this side. Now what will happen? Whenever the input goes from 1 to 0, when the clock goes from 0, 0 means 0 voltage means short circuit. So this positive will appear here and this negative will appear here. And voltage at the trigger output will be like this, negative voltage. This is negative and this is positive. And it will discharge immediately like this. So you get positive triggers and you get negative. So this duration is very small. I have drawn slightly larger duration. It is very small duration of the trigger pulse. When you look at the CRO, on the CRO, you will only see this type of pulse like this. The trigger pulses are very short duration pulses. They are in the positive +1 step from 0 to 1 and 0 to -1, like this. +1 and 0 to -. I think it is clear now. What is the difference between clocked flip-flop and triggered flip-flop? Clocked flip-flop means the clock is very long duration. This is long duration. Whereas this is very short duration. Trigger is very short duration. Okay. So what problem we had in case of JK flip-flop? Whenever the clock is 1 and J and K inputs are 1, the outputs were changing very fast. Okay, they were toggling from 1 to 0 and 0 to 1 very fast. We were unable to notice that. Okay. Now, instead of using clocked JK flip-flop, if I use triggered JK flip-flop, then what will happen? The trigger will be of very short duration. Okay. It will allow only one toggling. Only once it will toggle. Means Q will change from 0 to 1 or 1 to 0, and Q bar will change from 0 to 1 and 1 to 0. Okay, only once. So for every trigger, I will change the state of the flip-flop. Okay, it will get triggered. It will toggle. It will not toggle continuously. Whenever I apply a trigger, only then it will toggle. What was the difference between clocked and triggered? In case of clock remained high for long duration of time, and therefore the flip-flops were toggling very fast. Whereas in case of trigger, The trigger is very short duration, and therefore the flip-flops are not able to uh, toggle uh, very fast. They will toggle only once. For every trigger, they will toggle once. Once means if Q is 0, it will become 1. In the next trigger, it will become 0. In the next trigger, it will become 1. So for every one trigger pulse, it will change the state. Okay, the Q and Q bar will change the state. That is the advantage of the triggered flip. That's why instead of using clocked JK flip flop or clocked RS flip flop or clocked D flip flop, we prefer for triggered JK flip flop, triggered RS flip flop, triggered D flip. Okay, so better choice is triggered flip. So triggered flip flop is very nice as far as flip flops are concerned. I think this is clear. Okay. Now, as I have told you, there are two types of trigger. One is positive edge trigger. And second is negative edge. Okay. This is positive edge trigger. And this is negative edge. Okay. So what you have to add here? For the clock, you have to add on the RC circuit. Whatever R and C circuit I have shown you, that is nothing but the triggering circuit. Okay. It will convert your clock into trigger. It will convert your clock into trigger. So that modification you will have to do. I will draw the JK flip flop again. I will draw the JK flip flop again, but this is not a clocked, but it is a triggered JK flip flop. Okay, so here I have added this RC circuit. This is positive trigger circuit. The positive trigger circuit will pass only positive triggers. Okay, it will allow only positive triggers to pass through. Negative triggers will be blocked. If it is a negative triggered circuit, then it will allow only negative triggers to pass, and it will block the positive triggers. Correct. Now, how to block and pass the positive triggers and negative triggers? Just connect a diode. Okay, if I connect a diode here, if I connect a diode such that the output of the trigger circuit I connected to the P side of the diode, and N side I connected to the here gates. Okay, then this diode is going to conduct only during positive half cycle, or whenever its P is positive. So during positive triggers, the diode will pass the pulse to the gates, and during negative triggers, the diode will block the pulse. If you want to reverse this, if I want to pass negative triggers and block the positive triggers, then I will just change the direction of the diode. Okay, output of the trigger circuit I will connect it to N side of the diode, and P side I will connect it to the gates. Okay, now what will happen? During negative trigger, the diode will be forward biased, and all the negative trigger will pass through the diode onto the gates. Correct? Now the problem of fast toggling, which was arising in case of the clocked clocked JK flip flop. This problem will be avoided in case of triggered JK flip flop. Okay, so clocked RS flip flop, clocked JK flip flop, and clocked JK flip flop and triggered JK flip flop. Clocked JK flip flop, the problem is fast toggling whenever the clock is 1 and J and K inputs are 1. The outputs are changing very fast. And triggered JK flip flop, it will not change unless and until you trigger it once. For every clock, it will get triggered. Only once it will get triggered. So it will change the state only once. This is the advantage of the triggered JK flip. Okay. The same circuit diagram, except that I have added this block. Now, what will be the symbol for this? The symbol is like this. This is the J input. This is the K input. This is the Q output. This is the Q bar output. This is clocked, triggered, not clocked. This is J. This is K. This is Q. Q bar. And this is the clock. Okay. So this is a positive H triggered JK. This is a symbol for positive H triggered JK flip. If it is a negative H triggered, just you have to make this change. You have to add a bubble and this triangle like this. This will indicate negative H triggered JK. Okay. So if there is a triangle and bubble, it will be negative H. And if there is only triangle, then it is a positive. That is the only change in the symbols as far as positive H triggered and negative H triggered JK flip flops are sequence. I think it is clear. Now, if you look at the waveforms or timing diagrams, I will say. You look at the timing diagrams. Here I will draw the truth table, clock, age, J, A, Q, and Q1. If clock age is 0, whatever may be your J and K input, they will be in the last. If clock is going positive, positive age trigger. If J is 0, K is 0, will remain in the last. On the next figure, if K is 0, K is 1, Q will become 0, Q bar will be. On the next figure, if J is 1 and K is 0, then Q will become 1 and Q bar will be. On next figure, if both the inputs are 1, then it will change the state. This will become 0, this will become. On next figure, if this is 1 and 1, this will become 1 and this will become next figure. Again, all both there are 1, then it will change this. Okay, so from here to here, this is top. Okay. Okay. So for each clock, I will, this is your first clock. This is your second clock. This is your third clock. This is the fourth clock. This is the fifth clock. And this is the sixth clock. We will draw the waveforms. Okay. So let us assume that this is the last bit. So Q is 0 and Q bar is say 1. Let us assume this. These are the last. Now during the first clock pulse, if J is 0 and K is also 0, J is 0, K is also 0. So Q will remain in the low state, 0 state. Correct? And Q bar will remain in the high state, that is 1 state. Correct? This is the first figure, first clock. This is the second. This is the third. This is the fourth. And this is the fifth clock. Okay. Now change the states. J becomes 1 and K remains 0. Now J is 1 and K is 0. Now whenever J is 1, Q will become 1. Q will become 1 here. Whenever during only positive positive trigger, the Q will change the state. Q will become 1. And Q bar, which was 1, it will become 0 immediately. It will become. Okay. Now if I change the state, K1 and J0, Q will change from 1 to 0 and Q bar will change from 0 to 1. Correct? Now if I make both the inputs 1, 1, J also 1, K also 1. What will happen? It will toggle. It will become 1, then it will become 0, like this will become 0, and then it will. This is toggle. So in this way, you can draw the waveforms or timing diagrams for the JK flip or positive trigger, edge trigger JK flip. I think it is clear. If you have any doubt, you can ask. So today we will stop here, and again we will join tomorrow and continue the lecture on the flip-flops. Thanks.